Unit 7, Lesson 5, Three-Dimensional Space. The student outcomes expected from this lesson is for students to describe properties of points, lines, and planes in three-dimensional space. In the opening exercise, they give us the length of the side of a square, which is 20 centimeters long. So you have to remember what you know about squares. So all the properties that we know are that all sides are equal, you have right angles, diagonals bisect each other, they form 90-degree angles, they are congruent, they also bisect the angles that they intersect. So they have a lot of properties that I find to be the perfect polygon. So the first question is, what is the circumference of the circle when the circle is inscribed within the square? So you have to know what the definition of inscribed is. So this circle is drawn inside a square. We are asked to leave our answer in terms of pi, so we don't have to multiply that out. We know that the side of a square is 20. So that means all four sides are 20, and if that is the case, then we can also state that the diameter of the circle is 20. If I can move that diameter down, it would line up with this outside side of the square, whether it's top or whether it's bottom. The formula for the circumference of a circle is 2 pi r. And I know that 1/2 the diameter is the radius, so we know that to be 10. So all I have to do is plug it in, multiply these two numbers, and I get 20 pi. Okay, so that's the distance around the circle. I will highlight that in red. Circumference. Second question, what is the circumference of the circle when the square is inscribed within the circle? Okay, so alternatively, we're going to have a square and the circle around it. We know that the length of the square is 20, or the side of the square is 20. And we need to leave the answer as a radical in terms of pi. Okay, unfortunately, unlike what we did up here in the top one, we can use this value as the length of the diameter. We cannot do that here. So what you need to do is be able to get the length of the diameter using Pythagorean's theorem. So I'm going to draw a diagonal that will serve as our diameter. So we know 20 square plus 20 square is equal to c square. Our right angle is right here on the square. 400 plus 400 is equal to c square. We get 800, and we need to reverse the process of squaring a number, so I'm going to take the square root, in which case I will get 400 times 2. 400 is a perfect square, so it's 20 radical 2 is equal to c. So we're looking for the circumference. That is 2 pi r. I know that the diameter, which was the length of the hypotenuse here, is 20 radical 2. So that means r is 1/2 of that, is 10 radical 2. So 2 pi times 10 radical 2. We multiply these two numbers, and we get 20 radical 2 times pi as our circumference. So that is the length of the circle around the square. If you can unfurl the circle, you would get one straight line. Okay, so if you put a string around the circle, you get one straight line, and the length of that straight line, the same distance around the circle, hence the circumference would be 20 radical 2 times pi. With a partner, complete each of the following in the space provided below. Okay, so you can do this with a partner if you're sitting next to one, you can do it by yourself, you can do it with me. So the first thing we're going to do is sketch a point. I'm going to label it with a capital letter. The next thing is sketch a plane containing the point. So ideally, a plane goes on infinitely. It extends out infinitely. If you could picture just one wall, and we have many planes, and of course we have many walls, but with just one plane, when we draw a picture, we're going to have to condense it, but really it goes on forever, and you have to just visualize that. So a lot of times we draw something that looks like a parallelogram to replicate a plane in a two-dimensional situation, but as you know, it goes on infinitely in all directions. So now we're asked to draw a line that lies on the plane. So there's my line. I'll label it with a scripted L, and then draw a line that intersects the plane in the original point you drew. Okay, so I'm going to change the color here, and I'm going to put a line that goes through, to the best of my ability, that goes through the point I just drew, which was point A. Aha. And I'm going to label that M. The following three-dimensional right rectangular prism has dimensions 3 by 4 by 5. Determine the length of AC prime. Show a full solution and leave answers in simplest radical form. Okay, so AC prime is this line right here that I'm highlighting in red. I could see that's a diagonal from one corner, which is this corner for A, and the other corner, which is this corner for C prime. Okay, if we drop a perpendicular here, we end up with a right triangle. So we have two right triangles going on. I highlighted the first one in red. So that's A, triangle A, C, and C prime is a right triangle, and so is, and I will highlight it in blue, A, B, and B, C. So ABC, triangle ABC. As a result, we're going to use Pythagorean's theorem to be able to find out some information. In order for me to find the length of AC prime, I'm going to have to find the length of AC. So I already know that ABC, the lengths of the legs, here's my right angle right here, the lengths of the legs are 3 and 4, and that's a Pythagorean triple, so that means AC has got to have a hypotenuse length of 5. That hypotenuse also serves as the length of the leg of the triangle ACC prime. So now I have two values of the legs, and the length AC prime is the hypotenuse across from the right angle. So I'm going to use 5 squared plus 5 squared is equal to AC prime square. And I get double quarters here. Take the square root of both sides in order to simplify the square root of 50. We break this down to 25 times 2. I get 5 radical 2 is equal to AC prime. And that's the value of the distance. So now I ask that you go through each one of these properties. I know it's boring, but it has to be done. You have to be familiar with it in order to answer questions with regard to them. So the first property is that points PQ determine the distance of a line PQ and a ray PQ, a vector PQ, and a line PQ. So I think that you guys are familiar with that already. Number 2, 3 non-collinear points A, B, and C determine a plane. So if you have capital letters on a plane in 3 different ones, then we call it plane ABC. And in that plane, it determines a triangle also for ABC. Number 3, 2 lines either meet in a single point or they do not meet. So lines that do not meet and lie in a plane are called parallel lines. We also have skew lines that are lines that do not meet and are not parallel. So that's information or a new term you may not have heard of. So you either have parallel or skew lines. And take a look at this video. It's a demonstration on wolfram.com. Okay, by all means, please take a look and evaluate that. So 2 lines that have a single point intersect like this. Lines that do not meet and lie in the same plane are parallel, and then you have skew lines that are don't have a relationship. Number 4, given a line L and a point not on L, there is a unique line through the point that is parallel to L. Okay, so that's pretty evident. Number 5, given line L and plane P, then line L lies in P. Line L meets P in a single point, or line L does not meet P, in which case we say L is parallel to P. Please note that this implies that if 2 points lie in a plane, then the line determined by the 2 points is also in the plane. Okay, so make sure you're familiar with these pictures. 2 planes either meet in a line or they do not meet, in which case we say planes are parallel. Okay, so when you see the intersection of 2 planes, they meet in a line. I've seen that on a Regents exam, so please make sure you know that. Very important. And take a look at this video that's also provided. 2 rays with same vertex form an angle. The angle lies in a plane and can be measured by degrees. Okay, so that's good. Number 8, 2 lines are perpendicular if they meet, and any of the angles formed between the lines is a right angle. 2 segments or rays are perpendicular if the lines containing them are perpendicular lines. And number 9, a line L is perpendicular to a plane P if they meet in a single point and the plane contains 2 lines that are perpendicular to L. In which case every line in P that meets L is perpendicular to L. A segment or ray is perpendicular to a plane if the line determined by the ray or segment is perpendicular to the plane. So yeah, that's a lot of writing there, a lot of words. So here's an example of what that looks like. Okay, I would be familiar with that picture and note when things are perpendicular with lines and planes. Also take a look at this video that's been provided. 2 planes perpendicular to the same line are parallel. I've seen that on the Regents, so make sure you know that. And 2 lines perpendicular to the same plane are parallel. Okay, that's also been on the Regents. Make sure you take a look at this video. Any 2 line segments connecting parallel planes have the same length if they are each perpendicular to one and hence both of the planes. Okay, so that's pretty evident. The distance between a point and a plane is the length of the perpendicular segment from the point to the plane. The distance is defined to be 0 if the point is on the plane. The distance between 2 planes is the distance from a point in either plane to the other. Okay, so that pretty much is common sense. Okay, example 1. What can be concluded about the relationship between line L and plane P? Okay, so they are perpendicular because it intersects the planes where 2 other lines that lie on the plane intersect. So the reason as to why is that it intersects the plane where 2 other lines that lie on the plane intersect. That's how we know it's perpendicular. So what can be concluded about the relationship between planes P and Q, and the reason as to why? Well, they're perpendicular, and the reason as to why is because they lie separately beneath one another, and they have the same perpendicular lines that intersect them. What can be concluded about the relationship between lines L and M? They're parallel because they are perpendicular to the same planes. And what can be concluded about segments A, B, and CD? They are the distance between the planes. And line J lies in plane P, and line I lies in plane Q. What can be concluded about the relationship between lines I and J is that they are skew.